Hello, everyone. Our weekly webinar series. Today's topic is on response and control stability tool. For those who have attended these things in past, we'll follow the same structure. I'm going to take a few minutes break just to make sure people who have registered can sign in if they're having any issues. So we'll take a pause for about a couple of minutes, and we'll be back right after it. Thank you. Okay, welcome back. I'll just for Haroon to join us. There we go.
Yeah, good.
Yeah, we'll get started. Hello, everyone again. Thanks for joining us and welcome to our weekly webinar series. We're offering these webinar series during COVID-19 period on topics which are selected to help build awareness and improvement methodologies and tools that we have used in past. This is a similar structure that we've done in past weeks for those who have attended, who are regularly attending. And for those who are new, I'll still walk through it quickly, what the structure will look like. Today's topic is on response and control, a stability tool with a case study at a mining operation. And it is being presented by Haroon Khalid. Haroon, who's with me on stage, has been an integral part of ANI improvement team and has helped us deliver quality results on many questions. Haroon is a Lean Six Sigma Green Belt and is a McMaster University alumni. Graduated in 2015 with a Bachelor's of Chemical Engineering. And of his 5-year career, he has been part of the ANI team for almost 3 years. Today's topic about establishing stability is one of the key areas where Haroon has helped us in deploying response and control, which has enabled our clients to identify opportunities and implement them to achieve their improvement goals. Before I hand over the stage to him, a little bit on the, again, structure on our talk. We're going to start with the presentation on the topic. While the presentation is occurring, you can ask questions that you may have in the questions tab on the right side of your screen, and Haroon will keep an eye on the questions during presentation and will then answer them at the end. We usually have an opportunity to talk face-to-face and discuss any further questions or interesting points through a Google Meet session after our webinar's part is over. A link is present in the chat window for you to attend, and the socializing piece of our webinar at the end if you want. Without further ado, I'm going to hand this over to Haroon.
Awesome. Thank you for the introduction, Asim. So as Asim mentioned, I graduated in 2015. So on paper, I'm still considered quite fresh, I guess you could say. But I've been fortunate enough to be part of the Analyze and Improve team, where I've been, able to get exposure to a lot of different tools and skill set, and it's only really grown my curiosity to learn more. Some of my recent projects have been with our clients like Detour Gold, Hud Bay Minerals, like Nico Eagle, TransAlta, Technica Mining, and whatnot. And other than that, I've been actively involved with implementing response and control with one of our clients, and I've seen its benefits firsthand. And as part of the presentation, you'll actually see one of the examples directly from some of the work I did with one of our clients to achieve really outstanding results, and using this simple yet effective tool. And just enjoy the pre-recorded presentation, and I will rejoin after the presentation if you guys have any questions for me, and you can ask the questions, like Asa mentioned, to the tab to your right. On that, thank you very much.
Welcome, and thank you for joining us for this short introduction to Response and Control module. My name is Haroon Khalid, and I'll just be going through some of the basic content as well as an example from the mining industry from one of our clients. Response and Control is an effective stability tool, and when used correctly, it will help you identify opportunities and as well as help push your process to the next level of improvement. And within the management system, it falls under the stability toolbox. You begin by, setting some sort of expectations. Typically, after you have made an improvement or set new standards, you want to establish KPIs for your standards. And then the next step is to try to observe and understand and collect data against the standards we've set. Just for consistency's sake, I'm going to use or pretend our KPIs were the number of value-added hours within a given shift for an operator. So when you go ahead and try to observe and understand, what you're doing is essentially measuring against the expected value-added hours. So if our expectations that we had set was that we would always be attaining between 6 to 8 value-added hours per shift, If we fail to meet those expectations, we want to understand why, and a root cause essentially what are the issues we're facing, which is the reason why we're failing to meet those expectations. And over several days of observations, you should have enough data collected that you can now go ahead and try to quantify the pain or the issue or how big the pain or the issue is that we faced. So, for example, if it's an issue you notice that we lost an hour of value-added time in that day, but it's something you spoke to the operator supervisor and determined would only happen once a year, it's not something we want to invest time in. But if it's something that you only lost 10 minutes in, but it happens over and over, daily perhaps, then that's definitely a great opportunity to invest time in to gain that 10 minutes per day. And there are other similar examples. And it doesn't always have to be that you want to try to target issues that are your biggest waste or the most quantifiable, but also if there are wastes that you notice that can be eliminated through initiatives that are already happening within the plant, the mine, the industry, then you can definitely go ahead and still eliminate those less valuable or less less utility of those wastes that we can eliminate. Because there are already initiatives in place that will eliminate those wastes. We just have to make sure that those things, just things align so that we can target those wastes as well. And once you have quantified your waste and you want to begin the solutioning, you always want to make sure you have the right people involved in the room when you're doing the solutioning, whether it's a supervisor or superintendent who need to give approvals, or just the frontline workers who should be involved in the problem solving portion, because they're at the face of the problem. And once you've gone ahead and come up with the solutions to the biggest waste you've seen, you want to then go ahead and standardize and communicate it to everyone. So everyone within that role should understand why the change is being done, what the change is, and what the benefit it would be to them, as well as how it would help eliminate some of the frustration they feel. So you heard me mention the word value added, but I want to just go through this slide here just with a few basic terms that we will be using throughout. Just to make sure that we're all on the same page and we can understand when they are being said. So if within your typical day you have 8-hour shift for your operator, his shift is essentially divided into 3 broad categories: value added, non-value added, and waste. Value added is the work which we want the operator to be doing. We want to make sure he's enabled to do that work because it translates directly into the product that we're trying to produce for our customer. Non-value added but necessary, it still consumes resources. It doesn't directly contribute to the product, but it is necessary in order to enable it. This could be things like traveling sometimes to the work area. You cannot just teleport there, so you essentially have to have a necessary piece of travel. But you can still try to mitigate that wait. So instead of traveling an hour, you maybe create some sort of a shortcut or a different way of transportation that reduces that time to maybe just half an hour, so that time is translated then towards value-added activities. And lastly, the waste is the stuff that if we can, we want to eliminate entirely because it still consumes resources, but it has absolutely no contribution to the product we're trying to produce for our customer. Next, I just have a case study from an underground mine at one of our clients. And for this, during a Kaizen event to help reach stability and increase the average throughput at the mine, the team identified opportunities which would help eliminate the waste in their day-to-day activities and thus allowing them to do more value-added work. So as a part of this event, the team determined the expected value-added hours for the scooping part of the mucking process under different scenarios. And the example I have coming up just shows how we determined the process control limits for that mucking process. And just once again, note, responsive control only comes in after an improvement has been made, and this was the case in this scenario after that or during that Kaizen event after we had set some new standards, and it only helps enable improvement, not cause it. So for the process control limits, one effective way to determine process control limits could be through process mapping with operator input. Such was the case where we had operators in the room already and we were able to get their input. And the following example just shows the value-added hours attainable by a scoop tram in an underground mine. And it looks at 4 different scenarios where we had different equipment available and the different modes of transportation available to us and how the number of value-added hours we could get changed. And then we went ahead and allocated the time that is spent during the day on each activity to get the number of value-added hours we could get at the end of the shift after we had spent time on the non-value added as well as much of the value added work we could possibly do. So for the 4 different scenarios, I'm not going to go through it in too much detail, but in scenario one, it was when the scoop tram had a fuel truck available to fuel him, so he never had to leave his heading, as well as a Toyota available to drop him off to the heading. So the scoop always stayed in the work heading, thus eliminating the having to, travel mid-shift to get fuel, or even having to travel at the end of the shift and look for parking spots near the refuge station. And it goes through each of the different 4 scenarios, but on the right-hand side is where you can see the total number of value-added hours we were expecting given the scenario, as well as the time spent roughly on each of the activities throughout the day. So when your process is below the control limits, as indicated in the map or in the figure below, that's when we typically say our process is once again out of control, and we have some sort of waste happen throughout the day, which cause us to miss our target, and we want to understand and root cause what happened that caused the process to suffer. Similarly, if you are above the process control limits, you should have your operators or your observer try to understand, what was the opportunity there, what happened differently. It could be perhaps that we cut some corners that day, which helped us exceed expectations, or maybe there is an opportunity there that we hadn't noticed before that we may want to adapt into the process so we can continue to exceed those expectations and then push our process to the next level of improvement. So for the example of the scoop, we had set the expected value-added hours of 7 to 9 per shift, a range of 7 to 9. So anytime the process was the value-added hours at the end of the shift for between 7 to 9 hours, there was not much of interest. But if we failed to meet those expectations to fall within that range of 7 to 9 hours, we tried to understand what was going on. During the data collection phase and trying to understand that, we began collecting all the times when we failed to meet the expectations and try to create a Pareto of all the waste or the opportunities that existed there for that scooping process. So an example, so our observer went and spent multiple days with the operator trying to capture the out of norm instances and record the total value added hours at the end of each shift to measure against the KPI that we had or the expectation we had set. And once we had this data collected, it was used then to rationalize which opportunities would provide the greatest return. And the next few slides I have, it just shows you the Pareto analysis we conducted, as well as some of the opportunities we identified, and then going further into the solutions we had implemented. So for the scoop waste, we noticed that two of the by far the greatest waste were, one was breakdown for the equipment, and second was waiting for a truck, because the scoop is loading a truck. It's sometimes spend time waiting, and there's by design meant to be some wait because the scoop or the truck has to go travel all the way to a rock breaker and then come back. So it can't always be perfect that you have no waste, but if there is a large amount of waste above a certain number that we are happy with, then we want to quantify that, or we want to denote that as a waste in that waiting process. So the numbers you notice there in the table below, the 7.27 hours for breakdown and 4.15 hours for the truck, those are the number of hours we lost over a total of 68 hours of observation, not just the one day. And then you can also see the frequency just to see how recurring that pain is. So for our scoop, looking further into the breakdowns, we noticed that a large chunk, or nearly half the time, breakdowns were a result of the remote issues, whether it be programming or batteries. And then there were other issues like broken panels, lights not working, hose failure, scoop battery being dead. Anything that essentially caused it to prevent the scoop from being able to do value-added work was considered a breakdown. And additionally, when we went ahead and continued our observations, another opportunity we noticed was at the beginning of each shift, the very first load, a truck operator was waiting nearly half an hour, but for each subsequent load, the truck operator waited about 3 minutes to get his load. And the reason for this long delay at the beginning of the shift was the amount of time the scoop operator was losing to getting to his work heading as a result of either not being a priority for carpooling, or his scoop being trapped behind other equipment at the beginning of the shift, thus losing sometimes up to an hour. So the amount of time he lost on average at the beginning of the shift was about 30 minutes. And in order to help eliminate some of that the waste there, for the amount of time he was losing at the beginning of the shift, we came up with 3 different scenarios. So scenario 1, if the scoop was being fueled by a fuel truck and he was always being left in the heading, then the scoop operator would always ride with the truck operator, because truck operators have a passenger seat in the back. So instead of getting a carpool ride in a Toyota or any other method and having, getting to the work heading late, he could ride with the truck operator. Thus, it would ensure that they both arrive at the same time and then can begin work immediately instead of losing that time at the beginning of the shift. In scenario 2, if the scoop is driving back to the refuge with his scoop tram, then we wanted to make sure that he was parking close to the refuge and he was not being blocked in by any other equipment, because we were designating a parking spot just for scoop. That way, at the beginning of the shift, the scoop operator would be able to head out towards his work heading right away without losing any time. And if the scoop was dumping in a remuck, meaning there's no truck involved necessarily, but in this example, remuck ore storage or waste storage area, so he was, to ride with a truck operator that would be passing by his work heading. That way, once again, he's not waiting for, a Toyota and, 6 other people being dropped off. If he is being dropped off through carpooling because there is no option to ride with the truck operator, then make sure that the scoop is priority because it is a primary production equipment. And lastly, if once again we have our scoop tram being traveled back to the refuge, then get a designated parking spot and make sure that it's not being blocked in so that he can begin work right away. So through the successful implementation of responsive control, the mine was able to identify various opportunities to help them save costs, but also to increase revenue. So in the example you saw above, or the solution you saw above, where the operator was losing 30 minutes at the beginning of the shift, once implemented, the operator was able to gain nearly 30 minutes per shift, which translated to about $20,000 per day of extra revenue for the mine. So as you can see, there is a lot of opportunity once the tool is used correctly. And hopefully, if hopefully you are able to implement something similar at your organization and take the benefit of the responsive control as well. Thank you.
Okay, thanks, Arun. That was good.
Welcome.
I think there's some questions that are starting to come up. Just for and haven't done it yet, there is a poll question out there where we would like to know what else interests you. We picked 5 topics which we think it would be interesting to talk about. Please have a look under polls tab and see if there's anything which interests you, and give us your feedback. We will be updating this probably on the next webinar when we have it, because what we do is every so often, or every 4 or 5 weeks, we refresh the topics, then pick the next month based on that. So next week, the topic is actually not one of those 5 months, but I will be pushing the topics going forward. Okay, so let me start with the questions. Harun, there's one that says, in your experience, what were the challenges in utilizing this tool, and what would you expect to do differently?
I think challenges for my experience came not from the technical side, but rather from the social side. Whenever you're going doing observations underground with operators, there's always that almost wall they put up where they're reluctant, and there's always the risk that being there also causes a change in their behavior, and which could affect your data. So the one way I like to do it is always inform the operators, let them know they know this is what we're trying to do, so they understand and they're comfortable that I'm not there to observe their or record their performance in any way. It's purely just watching what's happening in the process, and it won't affect their job bonus. It won't be affecting their relationship with their employer in any way, and I'm just there as a neutral observer. I record data just to understand the issues they face, and then we'll help try to solve those issues for them. And at the end of the day, it's to help them reduce their frustrations. But yeah, like I said, the biggest challenges come from the social side, but it always is eliminated or mitigated at the very least once you communicate with your operators that you're spending the time with beforehand, to educate them on what's happening and why we're doing what we're doing, to hopefully make them feel as comfortable as possible. And then what I do it differently, I think in the future, if because I know now some of the challenges you face, I would do this preemptively, almost like objection handling. as a salesperson, you preemptively let them know and educate them beforehand, as opposed to when you're getting on site and you have an operator who feels a little bit uncomfortable that you're there, and then you're trying to kind of rehash and make them feel comfortable. You always do that beforehand, and that way the issue never arises in the first place. But yeah, that's a good question, and I agree. You're muted, Asim. And there might be some sort of technical issues, but in the meantime, I guess I'll fill in with some other common questions and whatnot that people do have. One of those, let me see. So as a part of the response control, if you guys have ever run into the term short interval control, a lot of the people are always curious, if our short interval control acts on, taking actions throughout the shift and it's on a more rapid basis, why don't we always use short interval control instead of responsive control? And the answer being, they are similar tools in the sense that they're both targeting issues, whether it be over a shift or a period. But responsive control is more long term, and it tries to solve a problem that you've encountered over a period. Whereas short interval control is more firefighting throughout the shift. Say your value added hours or your target was to get a value added hours of 8 hours during a shift, and mid shift you notice you're only at about 3 hours of value added hours, and you should be at about 4. So what can you do during that shift and that moment to make sure that you get as close to your original target as that you had set, as close to it as possible? And you may take measures based on the operator experience right there and then, or your supervisor makes a call to make some changes for that shift to resolve the issues or rather circumvent the issues to go ahead and get to your value added hours. But whereas responsive control might be looking at, over the last 10 shifts, we've failed to meet our target. What's the constant reason that we always failing to meet it? And then you solve that issue at the root cause. So almost like a short interval control, it works on a similar principle, but it's solving the daily shift issues and getting you to the target. Whereas responsive control solves that root cause to make sure you never have that problem, and then long term you're able to always achieve your target. But yeah, I think there's another question that came up.
Yeah, the thing is talks about. You can hear me now, right? We're good.
Yeah.
Okay. How do you see, imagine, observe these processes change with the growing use of IoT, Internet of Things, and more connected and intelligent sensors and data monitoring at the edge point of measurement? So I guess with the more digitalization, right? How do you see this changing?
Agree. So one thing is, the way we've currently done it is we go right to the workplace as observers to see what the operator is facing day to day for the shift. And you can use intelligence sensors to collect some part of the data, but if for the way the responsive control works is you have upper and lower control limits for your value added hours or your target, right? The KPI you set, say it's between 8 to 10 hours. So there might be times where you something bad happened and you should have been at 6 hours of value added hours, but also something really good happened and things went right, and as a result you were bumped back to within that range of 8 to 10 hours. Now, under normal circumstances, that shouldn't trigger any alarms for me because I'm within my range of 8 to 10 hours, and I shouldn't be really exploring any opportunities there. But in reality, an observer who's who's educated, who understands the process, would see, you know what, I know things went wrong, and I know also things went really right. So there's not only an opportunity to eliminate a waste, but also an opportunity to explore this a new process or a new way of doing things, where we can further push our process past maybe, instead of having a range of 8 to 10 hours being our target, it would be a 9 to 11 hours could be our future target. So those opportunities would never really be captured through using any sort of intelligent sensors, but they can definitely be used hand in hand with an observer to make their job easier, because as an observer, it gets tedious. You're sitting there for 8 hours to 12 hours, depending on the length of the shift, observing the operator. So there are times where having these sensors in place would make their job as an observer easier. They could focus more on other aspects of things where they're looking out for these opportunities, as opposed to just constantly noting down times as to what's a minute by minute study or however they're doing it in this case. But absolutely, there is a opportunity to use those sensors if we have the right ones available. And I know in short interval control, a lot of those sensors are used. I think we're working on a project right now where they're setting it up in equipment and whatnot to collect that data and use those use technology essentially to help with that.
Yeah, you already mentioned response and control, the two work together. I think the sensors are very, very important, and they can really help the short and flow control side of things because you're trying to make quick decisions. The live data coming in, response and control by definition, you're trying to build intelligence over time, and then reacting, and then problem solve, identification and selection, and then solving. Right. So the sensors can still data. Definitely, if you have the right, if you have them in the right places, right? It depends on what data is coming. So our audience, there's a project we're actually starting at one of our clients where they're going to be doing short and long control. They're digitizing the underground mine, and there's going to be a lot of data being collected, and we are going to try to do some response and control in that piece with the short and long control in the long term. The only advantage right now we have is we have telemetric data, we have the position data of the equipment, of the people. But if we had more stuff that the 4.0 will hopefully bring, we will be able to then tie that back into it. So yes, there is an opportunity there. It's just not. Maybe we can. I think the extent of it, as Harun was mentioning, is the proper application of this tool, right? Making sure that you're doing it right. You're not just identifying things after the fact. You're not just looking at historical data after the fact and saying, "Oh, something happened. What happened?" You need to understand the root cause. I think that's the important part. It doesn't matter how that trigger comes, as long as you investigate it. So to investigate, you have to be there, right? You have to understand the question. Yeah. And one of the questions here, which I think links to this thinking, is obviously people who are always there are the people who are the operators, right? Who are actually at the face of the problem underground or in a mill or wherever, you're doing response and control. How do you get them to start? How do you know they're mature enough that they're going to be able to do that themselves? So, people like us, or the third person doesn't have to go collect data.
So it comes down to really when we're doing the problem solving phase, or when we're tackling this issue and we have those operators in the room, I would look for the operators to show enthusiasm, the ones that really want to go and solve the problem. And if they come to me and they say, this is what I would like to be a part of the data collection phase, or I want to be able to help you with this. If they show that enthusiasm and they approach me, I think then that shows the maturity of the operators in the operation. But if I feel like, that interest isn't there on their part and they don't have that drive to go ahead and solve it, then I would always be questioning the data I got, and I would instead prefer having an observer go in and independently doing that observation and then providing that data in that case. But generally, if an operator shows interest, that for me is I think that's a sign that their interest for me is a sign that they're mature enough to go ahead, and then we'll go ahead and have them go to the observation. That eliminates having an extra resource, and then because the operator is already there doing the work, it allows for them to go ahead and provide that information for us.
Thanks, Roy. One more thing have you an example or anything which is non-mining? We by default we work in mining a lot, so it makes sense that our case studies are in mining. But could this be applied to a non-mining environment?
Yeah, so actually this was a more shorter webinar version of the module, but I have a full extensive version where we look at different examples. If you like, I can pull one up right now, just show you an example of a Pareto from a retail and also one from a car rental, something we both or everyone experiences going to. But give me just 1 second, I can share my screen with that once I pull it up here.
While you're filling that up, there is the meet for after the webinar if you guys want to join us on a Facebook.
Yeah, I think you guys should be able to see the screen now, but There's an example of a process map that's not from a mining industry. You guys saw like the 4 scenarios we had in the presentation where it showed, Toyota, fuel truck, and whatnot. Those were 4 different scenarios of a process map for mining industry, but here's one for car rental where, their process may start from a telephone call or, a person going on the website to get a book a reservation. Then, at the branch, the employees prep the vehicle for you as a customer, make sure it's clean, ready to go. Then in some cases, rental car companies will offer you to pick you up, to bring you over to their branch, to rent you the vehicle. So that process is also captured there. Rental contract and vehicle walk around. So when you are in the branch, you're getting your vehicle. When you're renting the vehicle, and then feedback for the customer once they rented the vehicle, and just making sure they're happy with the vehicle during the rental, not after, but during, just giving them a call back to see everything's going well. And lastly, when they return the rental vehicle, checking the vehicle in and then offering to rent another vehicle or book a rental for the future for the customer. That would be a process map for the process of renting or cycle of service for a rental vehicle, rental car company. Similarly, I have an example from a retailer. So this is actually a really interesting example. You guys are familiar with Zara, their retailer.
Go in slideshow mode so we can see it better.
Yeah, I might have to reshare because I selected the window. You guys good?
Yeah, I can see it.
Okay, perfect, awesome. So this one is actually for Zara, which is a apparel retailer, and what they have is a unique line of product where they take this product from the design room to the retail store within a period of almost 2 weeks, as opposed to where typical lines of products might take months from the design period to manufacturing, mass producing them essentially, and then bringing them to retail stores. With this one, there's only a limited quantity available because it's being done on such a short period. But one unique thing they do with this line of product is when a customer comes into their store and they try to get they're browsing the collection, a manager or a store clerk may approach the customer while he's looking at this product that's limited only, and ask them and get feedback from them. What do you like about this product? What do you not like about the product? And then in real time, they go ahead and upload their notes from the feedback from the customer onto their computer. So the designers who design the product are getting feedback in almost real time, relatively speaking, as opposed to months to almost a year having been passed. It's only been 2 weeks past since this product was launched. And then the designers can then use this feedback to modify the product accordingly so that the next iteration of that product, which is once again an exclusive limited time only product, is better and improved over the original one. So this is just a Pareto I created. It's just for the purpose of this example. I picked out what could be, some of the issues that the customers complain about. It could be the length of the dress, the color scheme, the print, the design of the printed design, placement of button or zippers. Any of those issues that the customers raise that they wish that were different or better in some way, the store clerks or the managers can capture that and then submit that to the designers, who can then modify their design for the next iteration. And this is just showing an example of the severity. So in this case, you can see a lot of people complained about the length of the dress, said it was too long. Some people said that it was a color scheme. Another unique thing that I added here was whether or not they made a sale despite making that complaint. So for dress length, a lot of people complained about it, but they bought the dress anyway. So maybe the retailer is interested in knowing, what, it doesn't really affect my revenue. Do I want to invest into this design change? Versus, it could be they decide that, what, regardless of whether or not it affects revenue, it's still a customer wasn't happy. I want to invest in this design change. It could just help them better make the decision as to what issue to target. But yeah, here's an example of non-mining example of how you can use this. Yeah, if you guys have any questions on this, let me know on the right side, or shortly when we join the Google, we can definitely talk about it there as well.
Okay, that was good. I don't see any other questions there, so I think we'll end it here. Thanks, guys, who were part of the presentation and talk today. As Harun mentioned, there's a link in the chat section for you to join Google Meet in case you would like to join one-on-one conversation, or if you have something to ask Harun or I. Otherwise, thanks again for joining. We'll share the next webinar hopefully tomorrow with you.
Yeah, take care. Bye.